Hi, welcome to Azure Concepts. We are going to see the Azure concepts, cloud concepts as an introductory section before learning Azure services and other stuff. To start with, let's first understand what is cloud computing. Cloud computing usually offers services such as servers, storage, database, networking, software, analytic services, and also intelligence related services. These services are all available to customer through internet or over internet. Customer shall avail these services on demand from anywhere and for any capacity. Instead of buying or owning as well as to maintaining a physical data centers and servers, you can access technology services like Azure services, something like computing power, storage, and a database on need basis from the cloud service providers. We call them as CSPs. Now, let's see what is CSP and a major cloud service provider. Cloud service provider are those people who provide technology services over internet, which include computing power, storage, and databases. Top 10 cloud service providers, which includes Amazon Web Services, Microsoft Azure, Google Cloud, Alibaba, IBM, Oracle, Salesforce, SAP, Rackspace, and VMware. These are the top 10 cloud service provider in the order in which they make the revenue as well as based upon the customer base. Now, let's see a quick rundown of cloud benefit. There are lots of benefit a customer can reap from the cloud service provider. Cloud computing offers number of benefits, which includes the items whatever I am listing in this slide. Number one is scalability. This is a, in cloud computing which allows you to easily scale your resources up or down as and when you need them without having to invest in and maintain expensive hardware. You can achieve scalability. Scalability is one of a benefit or important benefit for a customer who have subscribed any cloud model. Next come accessibility. Everywhere and anytime, as long as you have an internet connection, you can access the cloud resources. So this makes you to make your application available in a cloud service provider, and you can maintain avail the benefits of cloud service provider including development, testing, and deployment. Third and important one is no lead time. Cloud brings up one important advantage to the customer, so that there is no little lead time for getting applications it into the market. If you want to avail any services, you can choose the service and then order it and start using it. There is no need to wait for software procurement, installation, and then test the configuration of the installed software and then start using it. Just order it, you will have it. This is applicable for hardware resources like storage, virtual machines, and other stuff. Fourth one is related to flexibility. Cloud computing allows you to access your resources from anywhere with an internet connection, which allows for remote working and also enables you quickly move workloads between different geographic location. So that's on the flexibility. Next one, cost efficiency. Cloud computing allows you to pay for only the resources you use, which can save you money compared to having to invest in and maintain your own hardware. Additionally, it can also be more cost effective than traditional on-premises solution, as the cloud services is responsible for maintenance and upgrade of the infrastructure as well as upgrade of the operating system and other important software. Sixth one is related to speed and agility. Cloud computing allows you to quickly and easily spin up new resources, which can speed up the development and the deployment of new projects and services. Seventh one, collaboration and sharing. Cloud computing allows multiple users to access and work on a shared resources, which can improve collaboration and sharing of information and resources. Next come high availability and disaster recovery. Cloud service providers typically offer built-in high availability and disaster recovery options, which can help to ensure that your data and applications are available and can be quickly restored in case of any outage. Next one, security. Cloud providers generally invest heavily in security, and they provide enterprise grade security features that can be difficult and very expensive to implement in an on premises environment. The last and important one is related to fast connection. You can achieve fast connection between cloud based system and the end users, and also with the on premises infrastructure. And these are the top 10 cloud benefit if you are going for cloud. In cloud, pay only for the cloud services you use, which helps you in three different ways. One is it lower your operating cost. Second one, run your infrastructure more efficiently. And the last and important one, scale as your business needs a change. Now, let's see what are the cons or the drawbacks while using the cloud. There are four important things I am thinking of. One is there are complex pricing structure in terms of availing the resources or services from the cloud service provider. It requires some specialized skill in order to understand how the services are all charged, though you are going to get those services as pay as you go model. Second one, it requires specialized skills. Unlike traditional on-premises infrastructure development, whereas the cloud service or cloud using the cloud service provider network, you need a specialized skills, and that is uh, difficult to get. But in the market, since the cloud is picking up, and you can find the right resource for your requirement. Third one, knowledge of data residency requirements and the cloud security models. Some countries, like European countries, their laws are all very strict where you cannot move the data outside the European region. Whereupon you need to design your application and avail services of cloud service provider only from those countries. And the last one, limited customer support. There are many applications are all developed and put up in the app store are available with many cloud service provider. You can avail those services. Such a third party applications, when you start using it as part of your integrated application, getting the right support from the customer will be a big challenge. So these are the four important cons associated with the cloud. Now, let's see what is Microsoft Azure. Most of us knows it's a cloud computing platform. So it offers resources like servers, storage, and networking. Basically, it's an on-demand platform offering variety of services not limited to only server, storage, and networking. You will get machine learning, you will get analytics, you will get IoT related stuff. It also supports various programming languages, frameworks, tools, including both Microsoft specific and third party tools and frameworks. Originally, it was named as Windows Azure. Later, it was named as Microsoft Azure. You can have your own on-premises network and can connect to a cloud infrastructure environment. It does not stop offering services only in the cloud. It provides services which can integrate your existing on-premises servers, storage, and networking. We call them as a hybrid model or hybrid cloud. You can avail any services from Azure at any time for any quantity. That is, you can scale up or scale down any services. For example, during festival time, your website might experience more hit or very active. Azure ensures that all the requests to the web servers are serviced by scaling up the services so that there will not be any issue like server not available or server not reachable or server busy, something like that. Similarly, you can scale down after the festival season by reducing the server capacity. Originally, this Azure was called as Windows Azure and later it becomes MS Azure over a period of time. And we call Microsoft Azure hereafter. Let's take an example. Let's assume we need electricity whenever we need it. It may be for your lighting purpose or powering up your device or for air conditioners. So I will be using more electricity during morning and in night. In between, that is during when the day progress, I may not require much electricity or I may move out of my home and visit office. There, I don't require electricity. But during night, I definitely require electricity. So more power is needed during night. I am fine to pay more during peak hours. That is during off hours. Like that, Microsoft Azure, it's always available whenever you need it. It provides you the capacity of scaling up or down whatever you need. And it offers another important stuff to you, that is pay as you use model. And so this is a correlation between the electricity and the usage of the Microsoft Azure in simple terms. Next come why cloud environment is flexible. If you take a normal service provider, you need to pay cost to the services upfront. The services may be just setting up the server, setting up the data center, and other stuff. They take money upfront whenever you use their service. And even if you're not using the database or servers, you need to continue to pay to them. Or since you already paid the money upfront, even if you're not using the database server, means it is costed to you. However, if you take cloud service provider, for the services whatever you use, you need to pay. That is, it's a kind of pay as you use model. That is, pay for what you use. It's more flexible and elastic in nature. Like I said earlier, during festival time, you need more resources, more servers. And During off-season hours, you don't require as much number of servers whatever you use during festival seasons. So you can use cloud either as a standalone, or you can integrate with your existing on-premises data center. In cloud, you can use the cloud model for the way that you like. That is, if you are in need of a resource for a particular period, you go ahead and procure those services. It's more flexible because it easily integrate with on-premises servers and data centers, or you can use it as a standalone on need basis. And another important stuff, in cloud, server upgrades are automatic, whether it is a hardware upgrade or a server software update, something like OS upgrade. They are performed by the cloud service provider, and there is no cost to the customer. And over and above, it is best suited for hybrid model. And that's the reason that cloud environment is more flexible for many customers across the globe. Next come general use of Azure cloud. Here I have provided a list of general use, but the list is not limited to these five in number. There are many. You can use it as a server, be it an application or database or an integration server. You can use them. It can be a small server or a large server. Second one, you can use it for disaster recovery. You can back your data and recover it whenever you need. You can use a cloud model for business continuity planning. Third one, you can use a cloud to host your website, be it a full stack servicing website or a multi technology website. Or your website might be the entry point for your set of web application. Next one, you can use the cloud environment for setting up your dev test environment. You can use the set of servers for development environment to work across geographical environment. You can set those servers as a test pad between you and your customers. And the last one, you can use it as a storage platform, be it a live storage platform or an storage for archiving your data, or you can use the cloud for storage platform for storing your test data and the copies related to the test data files. And that is what the general use of Azure cloud. Next come, what are the key consideration while considering cloud options? Let's take the first one. It's related to high availability. It refers to a system or component that is continuously operational for a desired period. It's often used to describe systems that are designed to withstand to a certain level of failure or interruption without loss of data or functionality. The end user of the application may not feel there is a downtime have occurred. Next come scalability. In scalability, it is it refers the ability of the system to handle the increasing amount of load, typically by adding more resources such as servers or bandwidth. So it offers you flexibility of scaling up the number of nodes in your infrastructure whenever there is a need, and the nodes can be decreased if you don't require them any longer. Next come elasticity. It refers to the ability of a system to automatically scale its resources up or down in response to the changes in the demand. Like the one whatever I said before, like festival season you need more number of resources. Soon after the end of the festival season you don't require such much resources, and so you can decrease the number of resources and pay for whatever you are currently using. Next come agility. It's an important concept in many industry. Cloud allows organization to respond quickly to changes in the marketplace and stay competitive. Next come disaster recovery. Disaster recovery or DR is a process of restoring normal operation after a disaster or a disruptive event occurred. Maybe a climatical change like earthquake, flood, and other stuff, due to which if a data center fails, you can always resume your operations with the help of the cloud resources. And the last one is related to fault tolerance. It's an ability of the system to continue operating properly in the event of failure of one or more number of components in your ecosystem. So, due to these five major consideration, many customers prefer cloud, and they prefer cloud in addition to the on-premises infrastructure environment. Now, let's let's discuss in detail about all these 5 points. To start with, high availability. High availability, it refers to a system or component that is continuously operational for a desired period. It is often used to describe systems that are designed to withstand a certain level of failure or interruption without loss of data or functionality. Couple of more things that you need to know under this heading, high availability, which are: number one, it has the ability to keep the services running for extended period of time with very little downtime, which the customer may not feel that the downtime have occurred. It's a feature which can provide continuous user experience with no apparent downtime even when things goes wrong. Let's consider an example. Your company hosts an accounting application named App1 that is used by all the customers of the company or the employees of the company. App 1 has a low usage during the first 3 weeks of every month and a very high usage during the last week of a month. And so it is better to go for cloud environment when you are looking for additional resources at the end of the month or the last week of the month. Note another important thing related to high availability calculation. It's calculated as an availability is equal to uptime divided by uptime plus downtime. That is, when you are procuring a resource from a cloud service provider, how long it was up in a specified month, and if the service is not available on a specific day or specific hour in a day, these two parameters are used to calculate the availability. So it's a measure of system uptime for the users and services through which service level agreements are all calculated. This can be achieved through various techniques such as redundancy, failover, and load balancing. Next come high availability system are often used in critical applications such as financial system, healthcare system, and other industries that require constant uptime. That's about high availability. Let's move on to the next topic, that's for the scalability. In computing, scalability refers to the ability of the system to handle increasing amount of load. typically by adding more resources such as servers or bandwidth. Scalability is an important consideration for business and organizations that expect their workload to increase over a time, as it allows them to accommodate that growth without significant changes to the infrastructure. Now, in the traditional on premises world of infrastructure, if the performance or scalability was lacking to handle an increased user base, new hardware would be provisioned to add compute, memory, or storage or other resources to handle the increased load. The problem with this approach is it is not very efficient. If there are periodic spike in the traffic, then it necessity to add extra hardware, but those spikes are short lived and the extra hardware is basically sitting unused for a remainder of the period. This is not cost effective, and so better to go for cloud model where you can scale up as and when it is required. And so the cloud environment where you can add additional servers based upon the need. So you are scaling up the number of servers. So scaling up refers adding additional resources in the existing physical hardware environment or virtual servers. It may be just a CPU or RAM or storage. Scaling down means you are reducing the number or the size of CPU or memory or storage. It's not the removal of the resources from the data center. There is another concept called scaling out. It's a process of provisioning additional servers and capacity. Note down additional servers. So you are adding a new server with an existing one. So this involves adding new servers to the existing server, serving out the application demands. Scaling in is a process of deprovisioning existing servers by removing the subset of the server resources from the pool of servers. And that we really do not know when there is a need for scaling up or scaling down is required, or scaling out or scaling in is required. So to overcome all this, there is a concept called auto scaling. It's a way to automatically perform scalability actions such as scale up or down or scale in or out in an automated fashion based upon the demand what you are getting it into your infra provider. It's all available from the cloud service provider. And so adding up additional servers with the existing servers will be done automatically. And so it is a kind of scaling out. Now, let's see what are the different types of scalability. We have seen scaling up refers adding additional resources with the existing physical server like a CPU or adding additional memory or storage or resources. So here in this example, we are adding an additional storage with the existing server. The scaling up where you are increasing the CPU or memory or storage. So it is you are doing it in the same box, and that's why it's called as vertical scaling. Whenever there is no need for such much computing power, you might decrease the CPU, memory, or storage, and that means you are reducing that capacity from the same box, and that's why it's called scaling down. So if you look here, you have reduced the number of storage units from 3 to 2, and you will end up paying only for the 2, and which means that the number of storage units still remains 3, but the cloud service provider will charge you only for the 2, I mean the one that what you are currently using it. And we have already seen what is scaling down means. Here, there is a concept called horizontal scaling or scale up, where you have a server box and you are adding additional server box, which means you are increasing the capacity horizontally, and that's why it's called as horizontal scaling. Additional two boxes are all added in order to handle the new load. Like that, you can reduce that the number of servers from 3 to 2. That is, you are decreasing the number of servers, and so it is horizontal scaling down or scale down. And that makes a difference between vertical scaling, horizontal scaling, or scale up or scale down. Now, let's see some more key information with respect to scalability. If you look here in this diagram, we are scaling up. That is, we are having the same box whereupon either the memory or the storage is increased. It's all happening in the same box. It's a kind of increasing the capacity. Now, in the vertical scaling, you are increasing the RAM or CPU. That's all happen in the same box. Whereas in the horizontal scaling, you are adding up additional resources. So the scaling option and approaches, which include scale up for vertical and more, which is very faster to implement. Scale out, adding multiple number of servers. Scale down, in the same box, you are going to reduce the capacity. That is, reduce the RAM or CPU or memory usage. And that makes a difference between scale up, scale out, horizontal scaling, and vertical scaling. Well, more on the scalability. If you look here, the term scale up means to use more powerful single server or storage to process the workload that fits within the server boundaries. Scale out, again, a capacity expansion concentrating on addition of new hardware resources instead of increasing the capacity of available hardware resource such as storage or processing. It's all of two type. One is vertical scaling and horizontal scaling. Now, let's see the advantages of scale up and scale out. The scale out or scale up, it has three important advantages. First one is higher performance as resources are added in a single system, single box. Generally, it is easier to manage as all resources are in one place. Third important one, it often less expensive than scale out as fewer systems are all needed. If you take scale out, the advantages are increased fault tolerance, as failure of single system does not take down the entire network or entire landscape. It is easy to add capacity as more system can be added to the network as and when you need them. Third one, better it has a better ability to handle large number of concurrent requests as they can be distributed across multiple systems or in multiple regions. Now, let's see additional points that you should have to remember with respect to scalability. First one, scale up means to use more powerful single server or storage to process workload that fits within the server boundaries. You might have a server, it can serve to only certain level, and so you need to have a larger server that can cater the need of adding additional resources like multiple RAMs. So it should have to provide that many number of slots, thereby you can add additional RAM memory. As I mentioned earlier, during festival seasons, the website experiences heavy load due to concurrent users. This can be handled by scale out number of servers. That is, you are going to add additional servers. And also note down, scale out is a type of capacity expansion concentrating on the addition of new hardware resources. Next one, in scale out, it's a kind of scaling process which involve any Azure app service upsurge the number of virtual machines that can be spinned up for your application to take advantage to the need of the number of requests which are all coming in. When you go for horizontal scaling, there is no need for downtime. That is, there is no need to announce a downtime to your end users. That's why horizontal scaling is in many cases preferable compared to vertical scaling. Next, let's see the concept of elasticity. Elasticity refers to the ability of a system to automatically scale its resources up or down in response to changes in the demand. It allows a system to increase its capacity to handle sudden increase in the workload, which are not expected, and then decrease that capacity when the workload decreases, thus avoiding the waste of resources. Elasticity is closely related to scalability, whatever we have seen earlier, but it is more specific term that refers to automatic scaling or scaling of resources based upon the demand. So you need to be careful while using the term automatic. So automatic scaling means it's nothing but elasticity. So it's a commonly used to describe the behavior of cloud computing system which are designed to automatically scale up or demand based upon the needs of the application or workload. They can be achieved through various techniques such as auto scaling group, load balancers, or other tools that follow for automatic allocation of resources or services. Elasticity enables organization to improve efficiency of their infrastructure and reduce cost by only using the resources they need. And when they need them, you should have to go for it. You can also achieve the elasticity through various techniques like auto scaling group, load balancer, or any other tools that follow dynamic allocation of the resources. So in short, I can say it's nothing but dynamically grow or shrink based upon the workload. Otherwise, you can term elasticity is the ability to quickly expand or decrease your computer processing memory and storage resources to meet changing demands without worrying about capacity planning and engineering for peak usage. Now, let's see some of the benefits of elasticity. Number one, auto scaling the resources. That is to add a virtual machine, database capacity, and any other resource needed where you can go for elasticity. It helps in preventing downtime. Automatic scaling of resources enables preventing downtimes during peak system or resource demands. And the last one, deliver reliable cloud infrastructure. This ensures, yes, this ensures orchestration of Azure auto scaling on a predefined conditions and ensuring that system continue to work even under high heightened stress. And more important, if you look here, the need for the server resources may go up and down, and you should have to increase the resources and decreases over a period of time. And so here elasticity plays a crucial role. Now let's try to understand the scalability versus elasticity. Scalability and elasticity are related concept, but they differ slightly in certain aspects of system ability to handle changes in the workload. We know scalability is the ability of the system to handle an increasing amount of load, typically by adding more resources such as servers or bandwidth. This can be done either horizontally by adding more machines to the system or vertically by adding more resources to individual machines. And we have seen scalability allows a system to accommodate growth in the workload without significant changes to its infrastructure. On the other hand, elasticity refers to the ability of the system to automatically scale its resources up or down in response to the changes in the demand. It allows a system to increase its capacity to handle sudden increase in the workload and then decrease that capacity when the workload decreases. By this way, you can avoid waste of the resources. So elasticity is closely related to scalability, but it is more specific term that refers the automatic scaling of resources based on demand. In summary, scalability is the ability to scale the resources up or down to handle the load. Elasticity is the ability to automatically scale the resources up or down based on the demand. And so the term you have to remember when you're talking about elasticity is nothing but automatic. Now, let's move on to the next topic that's related to agility. So, what is it? It's a term which refers to the ability to quickly respond to changing requirement or market condition by delivering software very quickly and frequently through the use of methodologies something like agile development. So, agility is a key concept in cloud. It allows organization to respond quickly to the changes in the marketplace and stay competitive. Some key points that you should have to note down under agility are: it's nothing but the ability to react quickly. It's an ability to allocate or deallocate resources quickly. And third thing, resources adding additional resources at on-premise environment will take days or weeks or even months. But when you take the cloud environment, you can do everything in seconds or in minutes or maximum hours. You can request additional resources manually or through automated ways, like using APIs. So, in short, agility is a subset of scalability. And so, reacting swiftly to the changing environment is called agility. Now, let's move on to the next topic that's related to disaster recovery. Disaster recovery, otherwise called as DR, is a process of restoring normal operation after a disaster or other disruptive event occurred, something like earthquake, fire, natural any other natural disasters. In 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 it which I mean this natural disasters might include flood, fire, or disruption in the traffic due to inclement weather conditions. So this DR, which include procedures, policies, and or tools, which is used to minimize the impact of a disaster of an organization IT systems and their data. So the goal of disaster recovery or DR is to minimize the data loss or downtime and to restore normal operation as quickly as possible. These disaster recovery plans typically include procedures for backing up the data, restoring the system data, and providing alternate processing capabilities in the event of disaster. It may involve the use of backup sites, data replication technique, and other technologies to ensure availability of critical systems and data. DR is an important aspect of IT operation because it helps to ensure that organization can continue to function in the event of disaster. It may be due to natural disaster or cyber attack or power failure or any other disruptive event. It helps organization to minimize the impact of disaster on their operation and to quickly restore normal operation either from the same site or from a different geo region. So while talking about this disaster recovery, let's quickly discuss on cloud bursting. So what is it? It's a technique used to temporarily increase the capacity of cloud computing in the cloud environment in order to handle unexpected or temporary spikes in the demand. This is typically achieved by using hybrid cloud architecture when an organization on-premises infrastructure is connected to the public cloud. When additional capacity is needed, workloads are automatically shifted to public cloud, and when demand subsidies, they are returned to on-premises infrastructure. That is, this allows the organization only pay for the additional resources that they need when they need them, rather than maintaining a large expensive infrastructure all the time at on-premises. That is, go for cloud resources whenever you need or to serve a sudden spike in the demand. These cloud bursts can be triggered either automatically in reaction to high demand or by manual request process. If you see the bottom diagram, we have an end user connected to load balancers, which connect to the server, which in turn connected to a firewall, and whereupon it can connect to different application server and database servers. Assume the number of requests coming in from the end users hitting the load balancer is more. So what will happen? You can create a setup or acquire more resources from the cloud and start using it to serve the new demand. And as and when the demand goes down, you can reduce the usage of the resources from the cloud and go back to the on-premises setup. And this technique is called as cloud bursting. Next topic is related to fault tolerance. So what is it? It's an ability of the system to continue operating properly in the event of failure of one or more number of components in an entire ecosystem. Say for example, you have a large web application setup containing web servers, app server, database server, mail server, all the stuff. Here in fault tolerant, it's a measure of the system resilience to failures, and it's an important consideration in designing the critical systems such as aviation, healthcare, and finance. Fault tolerance can be achieved through various techniques like redundancy, replication, or failover. In your web ecosystem, if there is a problem with the mail system server, means automatic mail triggering may not be possible. Fault tolerance helpful for you to address the issue. It can quickly fail over to a newer mail system, thereby automatic triggering of the mailing will not be affected. If you look below diagram, we have a web application that connects to set up web servers using load balancer. And during fault tolerance, if any of the server fails, it look for a standby web server, thereby the business will not be impacted with the failure of any one of the node. And that's the concept behind fault tolerance. So in case of any issues with the existing web server, such as server failure or more workload, the load balancer shall be configured to connect to standby servers so that there will be business continuity and there is no impact on the business. Now let's see some example of fault tolerance. The first one, ability to respond to power failures. Power is a key important aspect in any infrastructure environment. If there is an outage, your system should not be affected. find the failover mechanism, thereby it can connect to a newer system where you can continue your business. So that is a number one. Number two, a step up. That is, during system failure, the ability to use the backup system immediately, where you can go for fault tolerance. Third one, enhanced fault tolerance. If a disk fail and a mirror disk take over immediately, this provides functionality despite partial system failure or graceful degradation, rather than an immediate breakdown and loss of function. The last one, high level fault tolerant. Assume multiple processes collaborate to scan data and output to detect the errors and then immediately correct those errors. That comes under high level fault tolerant computing. So these are the scenarios where you can go for fault tolerance. Now let's try to understand the difference between high availability and fault tolerance. High availability refers to the ability of the system to remain operational and accessible to users during planned and unplanned outages. This is often achieved through redundancy and failover mechanism. However, fault tolerant refers to ability of the system to continue functioning correctly in the event of component failure or partial component failure. This is often achieved through redundancy and the ability of the system to detect and recover from failures. A totally mirrored system is fault tolerant. If one mirror fails, the other kicks in and the system keeps working with no downtime at all. In summary, high availability is the ability to minimize the downtime, and fault tolerance is the ability to minimize the impact of component failure in the system. Both high availability and fault tolerant are important for ensuring that the system is reliable and can handle unexpected event. And with that, I close today's topic related to the cloud concept with respect to Azure. I hope this video is helpful to you for your cloud learning, interview preparation, or exam preparation. If you like this video, go ahead and subscribe and don't forget to ring the bell, and you will be notified as and when I publish a new video. This is not the end of the session. We will be continue our discussion on the cloud concept again tomorrow. Till then, stay safe and bye now.